Hey guys, we're Hacking Yackets, and I'm Fred.
I'm John. I'm Connor.
I'm Kathy Jones.
And we solved these challenges. Let's see how we did that.
For the CSAW challenge, our team used Ghidra's server in order to collaboratively work on the binaries. Each of us could check out the different binaries and make changes and check them back in so the whole team could see them.
Amnesia asks us to input a string that'll allow us to give us a long yodel. This yodel is calculated through the Amnesia check function, where it gets the ESC on it if it passes certain inputs. However, amnesia means doing something over and over and not remembering. So if we input our string multiple times that follows these guidelines, it has a certain character set, we get the right output.
This is the breakfast challenge function. It takes in a string, which is a combination of an integer and a sequence of characters after that. And both of those are passed into the encrypt function, which also which selects this string sequence in memory. Then the integer that you pass in is used to determine the amount of rotations that will be executed on that. And then the character sequence is used as indices, where each character that you input corresponds to a character to a anagram of banana in memory. And then, if we go back to the initial challenge function, that output of the encrypt function is then passed into this buffer and is compared to this. So if we can get the output of this encrypt function to be this, we solved the challenge. This is the challenge function for burst, which intakes a string of 3 space-separated integers, which are then converted to integers in the background. Correspondingly, they're passed into buffers of length 7, 4, and 7, which all need to be fulfilled. And then they're passed in. The important part is this equation down here, which needs to be properly fulfilled to pass the challenge, but it can't actually be solved with the constraints provided. So the way to solve it is by overflowing this one with a negative number.
So with an Esrom, the first thing that caught our attention was this string here, which is looped over within this function. And at each character, the green LED light on the hardware is turned on for a certain amount of time, depending on the value of the character. And so when we ran this, we realized that the light pattern was actually mimicking Morse code. Then we were able to translate the pattern into the string, send this over netcat : remorseful. This flood challenge has actually a challenge function. And at first look, it seems that it's focused on prime numbers because of this output string and also this loop right here, which calculates the amount of prime numbers between 1 and a numeric input value. But looking closer, there's a vulnerability. And right here, this actually mimics the standard C A to I function. But it doesn't check that the input value is greater than hex 30. And in fact, there are several special characters with hex values between 21 and 2F. So when we input an exclamation point, it didn't throw an error. And in fact, it printed out a string to the console, and we didn't recognize the string at first. But when we did a little digging around, we found it in here within this function. Back within the challenge function, if flood n is less than 2, then this variable is set to true, and then it sets the return value to 1, which solves the challenge. And in fact, when we followed our exclamation point with a bunch of other random input characters, we actually solved the challenge. So flooding the input with several characters apparently sets that flood len to greater than 400, which sets flood n to 0 and solves the challenge.
Quick analysis of the Parthenon binary shows that it prints a ciphertext to the user. Let's see if we can crack this. After attempting to brute force a few different cipher types, it is clear that this is a columnar transposition cipher with the key BDECA and the text being You mean to tell me that my classical cipher isn't secure?
Sequence asks us to input two numbers that match the input of the sequence array. This array is initialized over here in this function. However, if we copy it over into a C decompilation and print out the two array values it's looking for, 24 and 28, we get the right inputs, 0 and 38, and that gets us the answer.